Hi, this video is on graphing exponential functions. So this is assuming that you already know some of the basics. The basic form of the exponential function is this, just a quick reminder: b to the power x. B has to be a positive number, it does not equal 0. When b is greater than 1, the function will be increasing. When b is less than 1, the function is going to be decreasing. The domain of any exponential function is all real numbers, and the range of parent exponential function is going to be from 0 to infinity. So here's the general form of some exponential function. So the h here is going to be responsible for shifting the graph to one of the sides. So when h is positive, so when we're subtracting a positive number, the graph is going to shift to the right. When h is going to be negative number, so it's going to be x plus something, it's going to shift so many units to the left. When k is greater than 0, it's going to shift k units up. When k is going to be less than 0, it's going to shift it down. If a is less than 0, the number in front of b, then the graph is going to reflect about the x-axis. When a is greater than 1, the absolute value of it is going to be stretched vertically, and when a is less than 1, it's going to be shrunk vertically. Let's take a look at some problems. So first problem, we have 2 to the x plus 4. We can definitely state the domain, which is going to be all real numbers. So what happens here, this graph is going to shift 4 units up. That means everything's going to shift, including its horizontal asymptote. So normal, just if you do 2 to the x, it's going to be from 0 to infinity. This graph is going to be shifted 4 units up, so it's going to go from 4 to infinity. Is this function increasing or decreasing? Well, we have a base that's greater than 1. No other transformations besides a shift. This graph is going to be increasing. So when x goes to negative infinity, when we head to the left, the function is going to approach its horizontal asymptote since the function is increasing, which is going to be 4. When x goes to positive infinity, f of x is going to increase and it's going to go to infinity. Its x-intercept is going to be, we do not have 1, because the graph will never cross the x-axis, and its y-intercept, when you substitute 0 for x, you're going to get 0, 5. And this function is going to have a horizontal asymptote y equals 4. Let me point out a few values here that are important. Take a look at the range from 4 to infinity. One of these numbers will be 4, the other one is going to be infinity, and the horizontal asymptote will match the finite boundary of the range. So we can make a table of values now. Typically for something like that, I would recommend making the table of values starting from 0. Sorry, it's xy. 3, 4, 5, 6. Let's do one more. So 0 will be our middle value. Then we're going to have 1, 2, 3. And over here we're going to have -1, -2, -3. So from 0, at 0 we're going to be at 5. From 1 it's going to be at 6. At 2 we're going to be at 8. Now hold on a second, at 2, so it's 4, 4 plus 6, yeah, it's going to be at 8. And at 3, I think we're going to run off the grid, it's going to be 12. Over here at -1 we're going to be at 4.5. Over here we're going to be at 4.25, and here we're going to be at 4.125. So let's plot these points. So let's sketch the horizontal asymptote first. So it's y equals 4. And let's plot the points. I'm going to use a pen here. So 3, 12, I can't fit that. 2, 8. 4, 8. Actually 12 is right there. I can do that. 8. 1, 6. 0, 5. 4.5. 4.25. 4.125. And our graph is going to look like this. Okay, and there we go. Let's move on to the next problem. 3 to the power x minus 2. So here we have a horizontal shift, 2 units to the right. So this function is not going to have, the range is going to stay the same. So first of all, the domain is always going to be all real numbers. We can just write that. The range, since we're only shifting it left and right, is not going to affect the vertical values, so it's going to be from 0 to infinity. It's also an increasing function because the base is 3, which is greater than 1. So on the left side, the function is going to approach a horizontal asymptote at 0, and on the right, the function is going to approach infinity. The x-intercept here is going to be, we're also not going to have one. The y-intercept here is going to be 0, 1/9. When you substitute 0 into the, and we're going to have a horizontal asymptote, which is going to be 0, y equals 0. I'm going to make a table of values, so I'm going to give you a little hint here. So when you pick values, the best thing to do with this type of functions is 1, 2, 3, 4, 5, 6, 7 is so the other one I had 0 in the middle. Here I'm shifting 2 to the right, so I'm going to have 2 in the middle. So it's going to be 2, 3, 4, 5, and over here is going to be 1, 0, and -1. So when we calculate the values, this one's 27, this one's 9, this one's 3, this one's 1, this one's 1/3, this one's going to give us 1/9, and this one's going to be 1/27. So this one's about 0.11, this one's about 0.33. Alright, so we're going to draw our horizontal asymptote, which coincides with the x-axis. And plot the points. So at 2 we have 1, at 3 we have 3, at 4 we have 3, 6, 9. This one's going to be too far, so at 1 we're going to have 1/3, and here we're going to have 1/9 and 1/27. So it's going to start getting closer and closer to the x-axis, going to the left, and here it's going to rise like that. Next one, so we have this. So let's take a look at this problem. First of all, we have two transformations here. This is going to be a shift 2 units down. This here is going to be shift 3 units to the left. The domain stays the same. That number is not going to change. What about the range? Well, since we shifted this down 2 units, our range is going to drop 2 units as well on the finite value, so it's going to go from -2 to infinity instead of 0 to infinity. What else do we know here? This function is going to has a base that is less than 1. That means the function is going to be decreasing. And then what's going to happen is when we go to the left, it's actually going to head to infinity. But when we go to the right, it's going to approach our horizontal asymptote of -2. X-intercept here is going to be at -4, 0. Y-intercept here is going to be at 0, -15/8, which is actually approximately 1.875 negative. And as I already mentioned, our horizontal asymptote here is y equals -2. So let's make a table of values. So we're shifting it 3 units to the left, so I'm going to put 3 in the -3 in the middle, -2, -1, 0, and -4, -5, and -6. So if you substitute these values into the function, you're going to get the following values: 6, 2, 0, -1, -3/2, -7/4, and -15/8. So this is approximately -1.5. This one's going to be -1.75, right? And let's go ahead and graph all this. Let's start with the horizontal asymptote, which is y equals -2. And let's plot the points that we have. So -6, 6, -2, -5, no, sorry, -5, 2, so -5, 2, -4, 0, -3, -1, -2, 1.5, -1.5, -1 is going to give us -1.75, and it's just going to start getting closer and closer. So our graph is going to look like this. Okay. Moving on. Okay, you have to be careful with this one. You don't want to make a mistake. First of all, let's make sure we understand. The base here is not negative. This is equivalent of having this written as -1 times 2 to the power x plus 1. So we have a reflection about the x-axis. Okay, and we're also going to be shifting this 1 unit up. So let's think about this. If you take the graph that's going to go like this over here, and it goes from 0 to infinity, and you reflect it about the x-axis, then it's going to go from -infinity to 0, because the graph is going to be like this now. And then you're shifting it 1 unit up. So our range here is going to be actually from -infinity to 1. The domain, as always, all real numbers. So is this graph going to be increasing or decreasing? This is where you have to be careful. The base here is 2, which seems like it's supposed to be increasing because the number is greater than 1, but when we flip it about the x-axis, it's going to become decreasing. So this function is actually decreasing. And what happens now? When we go to the left, the function is going to approach its horizontal asymptote, which is going to be 1. When we go to the right, this is going to go down to -infinity. The x-intercept here is going to be at 0, 0, so is the y-intercept, and the horizontal asymptote will be y equals 1. Let's make a table of values. I'm going to put 0 in the middle since I did not shift it left or right. So what are my values? My values here will be 7/8. This one's going to be 3/4. This one's going to be 1/2. This one's going to be 0. This one's -1, -3, and here we're going to have -7. So this is this is 0.75. This is 0.5, and this is 0.875. All right, let's graph horizontal asymptote at 1. And plot the points. So at -3, we're very close to this. We got 0.75, 0.5, 0, 0, -1. Here we're going to have -3. And we're going to have -7. Okay, that's what I meant when I said that the graph is going to actually curve down like this, because we reflected that about the horizontal axis. That's why it's decreasing. Okay, let's take a look at this. So this one's a little bit more involved. We have also a number that we multiply by. It's a positive number. Let's figure out all the transformations here. I'm actually not going to focus too much on this 3. It's just a number that we're going to multiply by, but it does describe a vertical stretch. So what do we have here? We have a shift 1 unit to the left and shift 4 units down. The domain is going to be, of course, all real numbers. So the only transformation that, the only transformations that impact the range are going to be either a vertical reflection or up and down shift. So we have an up and down shift. So our range is going to be from -4 to infinity because we shifted the graph 4 units down. The base here is less than 1, which means the function is going to be decreasing. As x goes to the left, because the function is decreasing, this is going to go to infinity. As we go to the right with x values, the function is going to go towards -4. The x-intercept here is kind of tough. You have to actually use a calculator or very complex computations. It's approximately -1.710, and the y-intercept here is going to be 0, -2. And as I already mentioned, our horizontal asymptote here is going to be y equals -4. Okay, time to make table values. So we do shift this graph to the left 1 unit, so we're going to have -1 in the middle. So -1. Here we're going to have 0, 1, and 2, and here we're going to have -2, -3, -4. So substitute these values into the function, and our y values are going to be, this one's 49/8, which is approximately 6.125. This one's going to give us 11/4, which is 2.75. This one's 1/2, which we all know. This one's -1, this one's -2. This one's going to give us -8/3, which is approximately -2.7. And this one's going to give us -28/9, which is about -3.11. Okay, let's go ahead and graph horizontal asymptote first, -4. And plot the points. So -4, 6.125. So 2, 4, 6, right about there. Can be perfect here. -3 is going to be about 2.75. 2.75. -2 will be 1/2, so half. -1 is -1. 0, -2. 1, -2.7. And 2 is -3.11. So right about there, we can see how it's kind of curving the same way as all the other ones. Alright, and there's our graph. Okay. Our last example here is going to be this function. So we do have a vertical reflection here because we multiply the exponential part by a negative number. So we need to make sure that we keep that in mind when we're going to describe everything that we have here. So we do have a vertical shift 5 units up. We do have a horizontal shift 1 unit to the right, and we also reflect that about the x-axis. The domain, of course, is all real numbers. The range, we're going to get to it. Let's take a look. So we have 2 is our base, and it seems like it should be increasing, but we reflected it about the x-axis, so the function is actually going to be decreasing. Okay. So on the left side, when we go to the left, the function is going to approach the horizontal asymptote, which is going to be our value depending. Oh, hold on. So we got this. I got a little bit ahead of myself. So the range here is going to be, let's think about this. We go from 0 to infinity, right? We flip it about the x-axis, so we're going to go from -infinity to 0, and we shift it 5 units up. So it's going to go from -infinity to 5, which means our horizontal asymptote will be y equals 5. So the left side is going to go towards the asymptote, which will be 5. The right side, the graph is going to drop, and it's going to head down to -infinity. Our x-intercept here, kind of tough to figure out manually. It's going to be about 4.810, and our y-intercept is going to be 0.296, which is approximately 4.83. Alright, let's make a table of values. So we shifted it 1 unit to the right, so we're going to put that number in the middle, 1, and then 2, 3, 4, and here we're going to have 0, -1, -2. The values here for y are going to be 119 over 24, which is approximately 4.96. This one's going to be 59 over 12, which is approximately 4.9. At 0, we're going to have 29 over 6, which is approximately 4.8. At 1, we're going to have 14/3, which is approximately 4.7. Not the easiest numbers to work with, but, you know, can't help it. 4.3. 11/3, 3.7. And 7/3, about 2.3. Okay, so let's go ahead and plot all that. So we have horizontal asymptote at 5, and then plot our points. So at -2 we have about 4.96, 4.9, 4.8, 4.7. It's very slowly, gradually going down. Let's take a look at this. We got 2.3 at 4. So the graph is going to go down like this, and like that, and there you have it. I hope this was helpful.